This video we are going to see recursion, how we can implement recursion in Python and how we can improvise recursion algorithms using memorization. So first, for what is recursion? So recursion is something you are calling a function, and within that function we are calling the same function again. So for example, we are calling factorial, and factorial function, inside the factorial function again it's calling same factorial function but with different argument. Here it was 5. When it come inside, it will be calling with 4, n minus 1, 5 minus 1, which is 4. And you know that factorial of 5 is fact of 5 is 5 into factorial of 4. So that is what we are doing here, but for that we need to call the same function from inside the function. We will see how this is getting executed and how Python allocates memory when it's recursively called. So visualizing the Python program, first we can see that in global frame a factorial function pointer got created, and it is pointing to an object, function object, and it is coming to statement number 11, which is printing and calling factorial 5. It is a new frame got created where the argument is 5, and we are inside the function. It is calling, it is, since n is not less than or equal to 1, it is coming here, and it has to return factorial n minus 1 into n, so factorial 4 into 5. Since it's returning, since it has to calculate this factorial 4, it is again calling the same function and with parameter as 4. Earlier I just go back here, return factorial of 4 into 5, but factorial 4 we don't know. The program has to call the function again, so that is what happening here. Factorial 4, parameter is 4, is coming again here. 3 is again calling factorial 3, is again calling factorial 2. 2 is not less than or equal to 1, so it's false, so it will come here. And factorial of 1, n less than or equal to 1, yes, it's returning 1. Here it is this call for the factorial is returning. So this is actually the base condition for the recursion. We definitely need to have a base condition in order to avoid this call, in order to avoid infinite calling. So the base condition stop the looping calling recursive call, and it will come out with a return. so we are returning 1. So base condition is must for recursive functions. It's returning 1 and it is coming here, so this value is 1. For that call, the frame had n value 2, so 2 into 1 is 2, so return value is 2. 2 will be going here, and here already n is 3. 3 into 2, 6. 6 into 4, 24. 24 into 5, that is what this factorial is going to return. So we can see how that happens. When it's returned, that particular frame is gone, and it is now we have in this frame, so 6 into 4 is 24. Here this return value will be multiplied with this value, that is what here, whatever this function is returning, that value multiplied with current past para n value. Eventually, so 120 got printed. So this is how the factorial is, the recursion is happening. It is creating a separate frame for each function call, stack frame for each function call, recursive call, and returning when it met the base condition. Now we can see how the memorization can improve this scenario. Recursive call, for example, if you want to calculate factorial of 6, you are actually calling 6 into factorial of 5, but again somebody is again finding factorial of 5. This scenario we will be again calculating and doing all this recursive call. That is actually waste, because we already know, the previous call we already calculated the value for factorial 5. So here factorial 5 that you already computed here in your previous call. So if you can memorize or store this value somewhere, the next calls for this function can be computed or retrieved if it's already present in the stored memory, stored location. So it's better to memorize the values if we are using the factorials, that particular function, for multiple places in your application. So we'll see how this happens. Yeah, so this is the base condition. The base condition is, if it is first checking for its pass 6, it is checking whether the anybody has already computed the factorial for 6 and whether it is stored in memory or not, or it is a dictionary in our dictionary or not. So if it's already stored, so this will be something like 6 comma, I think it's 720 factorial value, 5 it is 120, 4 factorial is 24, something like this. It will be stored in this dictionary. So if it's already stored, it will be retrieved from here, returned from that memory location. If it's not, this is the base condition. Definitely it's a recursive call, because we are calling the factorial again from the factorial function itself. So it's a recursive call, so definitely we need to have a base condition. So this is the base condition, and if it's not there in the memory location and it's not a base condition, we actually need to compute that value with our previous same 5 into 6 into factorial 5, and factorial 5 is 4 into 5 into factorial 4, something like that. And the calculated value will be stored in the dictionary for the corresponding number, like this, and the value will be returned. We will see and how this is getting executed. Factorial global frame got created, factorial object, function object, memory dictionary, and empty dictionary got created. Here we are calling, we are just creating a variable for this factorial 6. Here only we are printing it. Sorry, here we are calling and storing the value in fact1. Factorial 5 is fact2. When you are calling factorial 6, it is calling factorial function. N is not present, mem is empty, so it won't be there, and it is not a base condition. It has to come here, the pointer coming here, the control coming here, and it's actually calling, recursively calling this function. This we have seen in our previous example. Only thing is, it is not calculated, it is just calling, recursively calling. Now this, it is coming to the base condition, n actually equal to 1, so it has to go inside this if. It's going in, and it is storing mem1. Factorial for 1 is 1, and it is returning 1, and that will be returned here. So 1 into 2 is 2. 2 will be stored in fact calculated variable, and that value will be stored to mem of 2. It's a dictionary, key value is 2, and calculated value also 2. So that is what this pair got created, and we are returning that 2, which is the memory value for factorial 2. The calculated value for factorial 2, that will be returned to factorial 3 calculation stack, and it's again calculated. Now 2 is coming here, 2 into 3 is 6. 6 will be stored in fact calculated variable. That variable will be, value will be moved to dictionary, key value pair 3, 3, comma 6, 3, 6. The key is 3, factorial for 3 is 6. That is what we are storing here. Same will be happening for factorial 4 as well, factorial 5 as well, and factorial 6 as well. Now you got a dictionary. When you are calling factorial 5 again, you already know factorial 5 value is 120, so you can directly go and fetch it from this dictionary. That is what the idea behind memorization. We are coming here. If n in mem, yes, n is there, 5 is there in mem, 5 values this. What is the value for mem 5? It is 120. we are directly getting it from, we are not recursively calling at all, we are directly getting the value from the dictionary and returning. We got 120 and we are coming here and printing. This is what memorization for recursive functions. Now we can see how a decorator can be used for memorizing. Here in this example we used dictionary and we actually put an else condition and inside the factorial function itself. But there is another technique where you can create a function. This is the function memorize factor, which actually accept a function. The function is actually our uh, recursive function for factorial itself. This function actually accepts number, but if we are passing 6, 6 will be coming here, and this is a normal factorial function we have seen in the earlier example. But what we are doing extra is we are defining a memorization function which accepts that particular function, and in that we are declaring a dictionary called memory, and in this function we are defining another function, inner function, which actually accepts a number. What happens is when you pass this as a function, this function to this, it can actually get this num value that will be passed here, and if num is not in memory, you will be calling the past function. That means this function, basically you need to compute the factorial. If it's already present in memory, you can just return that uh, dictionary key value, calculated factorial, already calculated factorial, and you are basically returning that inner function. Only thing is when you are using decorator, you need to give decorator simple and function just above the function you want to decorate. So this is our factorial function and we are just decorating it with decorator memorize factorial factor, that will be our this function. As you said, it will be accepting the function and also define a create a dictionary and has an inner function, and that function will be returned from this main factor memorize factor function. This is how we decorate the functions. We will see how this is getting executed and we can visualize and see this function definition. Global variable pointer got created, function object got created, in decorating memorize factor, fun will be pointing to factor num. That is what this memorize factor decorator memorize factor will be doing. It will create a variable fun and point to this variable. The fun actually will be passed to our memorize factor object. So this is how it will be linked. Now we can see it is getting executed and the memorize factor will be created with all inner all function definitions inside this. See, inner will be getting created, an object is got created, and a memory dictionary, empty dictionary got created, and a return value which will be a pointer to this inner function itself, and also you can see that the parent is f1. F1 is here. Now we are directly coming here. That is what happened. These two decorator thing do these many things. Now we are calling print factor 6. It is directly calling the inner function, which is this. Because the factor is pointing to inner. We are calling factor. Factor is pointing to inner. That's why it's calling inner. And num is not in memory, so it has to call fun num and calculate the factorial. Fun. What is fun? Fun is factor. Factor 6 is getting called. This is actual factor function. So basically when we call first time the factor, global frame factor is pointing to inner, not the actual factor function. So the global frame factor calling inner, when you call fun, then only the factor is getting called. That is what happening, and you can see recursively calling. This is same thing we have seen in our previous example. It's not in the first calculation, so it's not there, so it will be calculating, calling again factor. Now it will be coming to the base condition. Here factor 1, factor 1 is returning 1 here. Returning 1 and it will return to here. Memory of num is 1 1, that will be returned. It will be coming here. Here it is 2 into factor of 2, factor of 1. It's again stored that particular value 2 in mem of 2. So we are basically, last example we have seen the dictionary. Same way we are storing the values to dictionary, but in a different method. We are using decorator here, Python decorators. It's coming return. It's just following. Why this is returning to here? Because this will be returning to here, because we are calling fun only calling this factor, so it has to return here, and return value will be moved here, and this inner function will be returned to here. See, inner function is returned here. That will be this. we got 6 factorial as 720. Now we are calling fact 5. We already have this dictionary in place. So we will see what happens. It is calling inner because factor is global factor is calling inner function, pointing to inner function. So it will call inner, and num not in memory. Num is 5. 5 is already there in memory, our dictionary. So it will it will return mem of num, mem of 5, that is 120. It won't go for calculation. Yeah, it's coming to return. It's returning to whom? It's returning to whom it's called from here. The inner parent F1, which is returned to here, which is returned to the print. So it's got printed as 120. So this is how we can use decorators in Python for memorizing for recursive functions. Thank you for watching this video. We will see in next video. Thank you.